So now we will learn about empty set. Okay, this is empty set. A set which does not contain any element is called empty set, null set or void set. These are all same name, that is there are that empty set, null set and void set are same. Okay, so we will represent this set, a set which does not contain any element, that is called empty set, null set or void set, that is represented by phi, or we can represent it by like this. There is no element in the set. So let's talk about any example. Let's take a set A. We will write in a set builder form x is a member where x square is equal to 4 and x is odd. So in any this is x. Okay, for any value of x, which is odd, this equation cannot be satisfied. Okay, for any value of x which is odd, this equation isn't satisfied. So this set will be a empty set. So we are talking about now finite set and infinite set. A set which is empty or consists of a definite number of elements is called finite, otherwise the set is called infinite. So let us talk about an old example. V, the set of all vowels. So this is the set of all vowels of English alphabet. So in this example we can see there are 5 number of distinct elements, definite number of elements, 5 number of definite number elements are present. So it is a finite set. Okay, this is a finite set. And how we will represent the number of elements? This is n of v. We will write like n of v is equal to 5. There are 5 number of elements. Let us take another example. A is equal to x. X belongs to n. N means x is a natural number, and x minus 1 into x minus 2 equal to 0. Okay, this is a example. By solving this solving this not, if we represent this set in tabular form, we will get this. These 2 elements are in the set A. Okay, if A is defined by this, then how many numbers are in the set? There is only 2 members. So n of A, number of elements in the set A, distinct elements, will be 2. What is the example of infinite set? So infinite set, suppose the set of natural numbers, it will start from 1 2 3 4 5 6 and it will continue up to infinity. So this is a infinite set. The set of all integers is an infinite set. So we can take a lot of examples about infinite set as well as the finite set. So we are taking 2 sets A and B are said to be equal if they have exactly same elements, and we write A equal to B. They have exactly same elements. Let us take a set A 1 2 3 4, and there is a set B 3 2 1 1 2 4. Are those equal? Yes, they are definitely equal, because in set neither repetition nor order affect the set. If you repeat the members, that doesn't mean that set is a large one. Repetitions doesn't make the set a different one. All the elements should be distinct, like 1 2 3 4. If you rearrange this set like 3 2 4 1 4, then it will be not a different set, it will be same set. The collection of objects you can collect in any order. Okay, order doesn't matter. Okay, and the repetition doesn't make the set larger. Okay, they are the same sets, they all have same elements 1 2 3 and 4. Okay, so these will be equal sets, A equal to B. Okay, so A is 1 2 3 4, and if B is 3 2 4 1, then even then these sets will be equal, because order doesn't matter, repetition doesn't matter. Okay, we will talk about subset. A set A is said to be subset of a set B if every element of A is also an element of B. Let us take an example. A is equal to 1, 3, 5 and B is equal to 1, 2, 3, 4 and 5. Okay, then we will write A is subset of B. This is the symbol of subset. Okay, not like this, this will be like this. This is the symbol. How this is A is subset of B. Okay, this symbol is called subset. So from this example we can write if A belongs to A implies, this symbol means implies. Okay, implies A belongs to B, and this is the definition. If an element is present in A, if every element of A is also an element of B, if A belongs to A, any element in this set is belonging to A, then that element must belong to B. If 1 is in A, 1 will be in B, 3 is in A, 3 will be in B, 5 is in A, 5 will be in B, must be in B because A is subset of B. This is the concept of subset. So we will talk about power set. The collection of all subsets of A is called power set of A and denoted by P of A. You must remember that every element of power set is also a set. Okay, if we take a set A which is 1, 2, then the power set will be P of A will be 5, the singleton set, the null set, this is the null set, then the singleton set 1, then the singleton set 2, and finally the set A. This is the power set of A. All subsets are contained in power set. All subset of this set A, we write this in P of A. Now remember, in here n of A, how many numbers or number of elements in the set A? There are only 2 elements. Okay, so the number of elements in the power set will be n of P of A is, before that we need a formula to understand what is going on. If n of A is equal to m, then n of P of A will be 2 to the power m. Okay, this is the formula to calculate the number of elements in the power set. So in here, in place of m we have 2, in place of m we have 2, so the formula will be 2 to the power m, that is 2 to the power 2, that is 4 number of elements, and you can see there are 1, 2, 3, 4 number of elements in the power set. So we are talking about now universal set. We are talking about universal set. A universal set, a set consisting of all the elements under discussion, is called an universal set. It is denoted by U. Suppose we are taking an example. A is a set 1, 2, 3, 4, 5. This is a set of natural numbers up to 5. Okay, so in this case we can take the universal set as set of natural numbers. If we have a set B like this, -2, 0, 1, 5, 6, we can take universal set as set of all integers. This is some example. You can take anything as universal set, but the sets will be a basic set, a bigger set, which will contain this set, all the sets under discussion. Okay, any set. So here if we have a C like this, that will be 1, 2, 7, 17, 60. This, in this case, the universal set will be a set of natural numbers. We can take set of all integers. There will be no difference. There will be, obviously there will be difference, but we can take a bigger set than this, and it will contain these sets or all the sets under discussion. That is called universal set. Okay.